One more thing, the last video I have uploaded on the YouTube. Okay. Prableen Kukreja. You can search on the YouTube, you'll get it. And the last probability video, the first lecture basically is uploaded. And again, if you have any doubt, we can discuss it anytime. So yes, as we were discussing, what are the favorable outcomes in the infinite space? I want to calculate the probability of selecting a real number, like 0.5 between 0 and 1. So what are the favorable outcomes? 0.5 is coming how many times between 0 and 1? Yes, come on, one time, yes. And what are the total outcome? How many sample spaces are there? How many total outcomes are there? Infinite, yes, absolutely correct. So what is the answer? 1 over infinity. Can I say 0? But if we think that we are saying at one side that probability of 0.5, and we know that 0.5 is coming, and then we are saying that probability of 0.5 is 0, is it not countering the statement that one side I'm saying that 0.5 is actually coming, and one side I'm saying that the probability of selecting is 0.5. What are your views about this? What do you think? Like, why it is 0? And should it be like this? Come on. Any one of you can unmute and we can share our views, and that is how this session we'll proceed this session. Are you understanding like what I'm trying to say? As you guys only told me that okay, this is 1 over infinity. 0 means that even won't happen, right? 0 means it will not happen, but event will not happen. But is it true that event will not happen? Actually, the event is happening. 0.5. This, when we talk about probability like this, here we are talking about the concepts of basically, this is the challenge here which we are facing. We are trying to here apply concepts for finite sets. This is only the concept when we apply for the finite set. That is what we were trying to apply here. But it is actually not the true case. 0 is not the probability, I can say here. That is why we come up with the term which is told in the class, that is sigma algebra, or I can say measure theory. So first of all, I'll give you the intuition behind them. And then we'll move towards it. What it says intuitively, probability of selecting point is 0, as we saw that, not because it is impossible, but because the set size is very large. Like set of outcomes is very large. That is why we are saying that we are approaching to 0. That is what measure theory says, or I can say sigma algebra says, that our answer, if I'm applying to like finite set, then that is okay. Like 1, 2, 3, what is the probability that 1 will come? That is 1 by 3. 2 will come, that is 1 by 3. But when we apply to here, it doesn't mean that it is impossible. When we come to measure, what is the intuitive understanding behind this? That we are saying that because the sample set is very large, set of outcomes is very large, that is why we are getting that of selecting, and that it is actually applied for the finite states. Now let us try to understand that how we work with the like infinite sample space. You got the intuition, like why we are first of all trying to understand these infinite space. Okay, let's proceed forward. Now, instead of working on the like single element, let us try, now we'll work on the subsets or events directly. So now let us introduce the term sigma algebra. Can someone tell me what is like about sigma algebra something, as it was discussed in the class? I'll just revise the concept so that the questions will be like, we'll practice the questions, it will be easy for us. Yes, come on.
Every subset has its own complement in it.
Yes, every subset is having the own complement, and I can say that like it is also, every subset is also having the union. Is it right? Like
Yes, ma'am.
is yes. So collection E of subsets of omega, that is what we are calling as sigma algebra, and it has property about complement. That is what we have done, and union basically. It is closed under union, and it is basically it belongs to the sample space here. And here we also come along with the union that is countably infinite, that we have already discussed in the last class. I think it might be easier to understand for you. I'll not repeat that. So as I can say that E is having phi sample space A complement for any event for any A which belongs to the sample space. Now, can anyone tell me that P of A is basically here half? No, we can't say that it is half and half is, because it's not uniform. That is not given to us. That is a simple example that I'm taking. Now, let us take one more example. This is also discussed in class only. So basically pick a random number, x belongs to 0 to 1, which is smaller than 0.5. Can you tell me here what will come in that subsets? As you told only, one of you, that it contains complement, it contains the union and everything. And as I told that it is basically phi, like 4 elements are there here.
Yes,
Everything, nothing, and A itself and its complement. Now, can you tell me what is this? It's
it will
also
contain a null, then its union, which is the sample space 0 to 1,
okay.
and then 0 to 0.5, and its complement, which will be 0.5 to 1.
Yes, absolutely correct. So it will contain 4 elements as we have discussed: null, like whole sample space, a event which is going to happen, and its complement. Okay, now if I say about uniform distribution, just I'm revising, brushing up the concepts. What do you mean by uniform distribution? Okay, if I say about this only, I'll write it and then one of you can explain that. Can you explain this, what I have written here? Can someone tell? Don't hesitate, anyone. Just tell what I have written. How it is
In
uniform?
this, the AB is A, AB is the subset which will be given that A and B are between 0 and 1. And A can be equal to 0 or B, and B can be equal to A and 1. And they are the union with the null set. So everything will be A and B. And then the probability of A, B will be B minus A.
How would the probability of AB is B minus A?
Mm, because both of them can be equal. So if we subtract it, then it will be.
Yes, yes, yes. Yes, you are correct, Tully. Actually, here we are talking about uniform distribution. As you told that both of them are equally having the chances of having them equal. If we talk uniform distribution, we can also say that uniform, okay, someone has written the probability of interval is the probability to its length. Absolutely correct. It is directly proportional. The probability of that interval, I can say, is directly proportional to probability of the length of the interval. So that is why if I say that, or okay, I'll give you the example. If I say that I'll take the range 0 to 0.5. So what is the probability of selecting the point from that? That is basically 0.5 minus 0. That is 0.5 only. Because yes, absolutely correct. Because sample space is distributed uniformly. So if I say that what is the probability of finding a point which is from 0 to 0.5, that is 0.5 minus 0, that is uniform distribution. So that is 0.5 only. So similarly, that chord example is also explained in the class. That is the same only, that how we are writing the events for this sigma algebra. That is the same, that phi will be written and universal like sample space will be written complement, and its like event will be written. So I'll not discuss that. Let us jump to conditional probability and try to solve the questions for that. This was just the basics which was given. Actually, measure theory is very vast topic. It was just given for the like to have the intuition behind, intuitive understanding. Like I tried to explain you why we jump to this sigma algebra and measure theory for the infinite space. Only the basic overview is given, so that I'm limiting to that only according to the class. So conditional probability. Can someone tell me like why we come to let us try to have everything like why. The question should be why we are jumping to conditional probability, why we are jumping to, why we jump to that sigma algebra. The same way why we jump to this conditional probability, why it is needed. Can someone tell me? Yes. Okay. Idea that how probability changes if extra information is given. Absolutely correct. If I'm given the information, then how it is affecting my probability. Can it also be happen that the extra information is not affecting my probability? As you have told that probability changes if extra information is given. Is it true always, or sometimes it's not true? Yes, come on. One of you have written that how probability changes if extra information is given. If something is given, how the probability is changing. Now, my next question is Is it always true that my probability will change if the extra information is given, or it's not always true? And why it is not always true, and in which case it is always true? No, not always true. Yes. Okay. Yes, you are correct that it is not always true that when information is given, then it is like when events are independent. Yes, when events are independent, it is not true. Like the professor only told in the class. Suppose let us try to revise those both the topics when it is true and when it is not true. Suppose that both the coins, I'll take a normal coin, which is having head and tail, and the second event is I'm taking that coin is having head and head. Basically, it's biased coin. I randomly am picking one of them and toss to get head. So what is the probability that I pick coin B? So basically I'm picking the coin and head is coming. So what is the probability that I'm picking the coin B? Okay, we'll go to it. I think I have to, is like, I'll just ask you, is it more or is it less? First of all, I deviated from the topic. Okay, if my first head is coming in the normal coin, what is the probability? We'll come up to that afterwards. That tail comes second toss, when I'll toss it second time. Is it dependent on one? This is first event. This is second event. Is it dependent on first event? No. Yes, absolutely correct. They're independent. The first time I'm tossing, that head is coming. It doesn't mean that the second time head or tail will come. They're independent events, as you have told. So basically, the probability of coming head or tail doesn't depend on the first event which has occurred. Now, coming to the definition of conditional probability, probability of A given B, I can write it as we have also studied that it is related to intersection, not exactly basically. Like one event has already happened, and then what is the fraction? Some other event will happen. That is what we are trying to study. So probability of A given B, we can write it as A intersection B divided by probability of B, and probability of B, we can write it as any doubt? Any doubt? What I have written, can someone explain me? So that we proceed forward and try to solve as many as problem related to conditional probability. What is this in the denominator?
We can write the set B as the complement, as the intersection of B with A and B with the complement of A. So together they'll make the set B.
Yes, that we can see here also. This was A intersection B. and this was A complement intersection B. Together they are making the B set. That is what we have written here. Now coming to the basic problems, let us try to solve that. So suppose we have a dice, 6 possible outcomes are there, as you know. And which are equally likely. So if we are told that outcome is even, what is the probability of getting outcome as 6? Can someone tell the answer? Yes, 1/3. It was simple only. Conditional probability applied. I think every one of you get it. That the outcome is even, that is 2, 4, 6. And the outcome is 6, that is 1 out of that 3. So given that. Now, one more thing I'll try to explain, that basically it very follows the additivity axiom as well. Like suppose I'm writing probability of A1 union A2 given B. It is basically probability of A1 given B plus probability of A2 given B. Let us first try to understand how. Can I write it as A intersection B, like A1 union A2 intersection B over probability of B by conditional probability? Now I can write A1 intersection B union probability of A2 intersection B over probability of B. A2 intersection B over probability of B, which can be written as probability of A1 given B plus probability of A2 given B. Of the disjoint sets, basically. So now coming to another question. Suppose we toss a fair coin 3 successive times. We wish to find probability of A given B. A event is more heads than tail come. B event is first toss is head. This is also very simple. Yes. Okay, which formula you're asking? This one, this is nothing. I'm saying that they follow the additivity principle. Like I can say that if A1 union A2 given B is there, I can write it as A1 given B plus A2 given B. That is what I have proved here. Is it clear?
Yes, ma'am.
Okay. Now, let us try to solve this. Yes, come on. We'll try to solve as many as questions so that there should be enough practice. This is also simple only. I'll give you first time to solve that, then I'll solve. Yes. Waiting for the answers. Come on, this is easy one only. 3/4, correct. Absolutely correct. What about everyone? Let's solve it now. So we are tossing a coin 3 successive times. So can I say that the sample space here is head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. And the probability of B occurring is first toss is head. First toss is head means 4/8. Total is 8. And 4 times I'll get 4/8. And now what I need to find is more head comes. What is the probability of A given B? Which means that I have to find A intersection B and B by conditional formula. I got this. What is probability of A intersection B? Which means that more head comes than tail and the first toss should be head. Which means 1, 2, 3, 3 only because this is not the first toss is head. So I can say that is equal to 3/8. And here we come by 3/8 by 4/8, that is 3/4. Should we proceed or any doubts? We can proceed, yes. One more easy question, then we'll make our level high by some medium or high level question. Okay, a fair. This we can solve through actually conditional probability also, the next question I'm going to give, and as well as some intuitive understanding also, like, so let's see. And a fair four-sided die is rolled twice, and we assume that all 16 possible outcomes are equally likely. Okay, I'll discuss. I haven't seen actually assignment 1. Okay, at the end of like last half an hour or 15 minutes, we'll try to discuss the assignment 1. A four-sided die is rolled twice and we assume that all 16 possible outcomes are equally likely. let x and y be the result of first and second rule. Now we wish to find conditional probability A given B, whereas A is basically max of xy is equal to m, B is equal to min of xy is equal to 2, and m takes each value for 1, 2, 3, and 4. We have to find that. Yes, come on. Four-sided dice roll twice, and we assume that all 16 possible outcomes are equally likely. X and Y, they are the results of first and second, and maximum of X and Y is equal to M, which can be like for M is equal to 1, for M is equal to 2, you have to find for M is equal to 3, and then for M is equal to 4. Maximum is 1 and B is equal to min of XY. We have to find A given B condition.
Can I answer verbally?
Yes, yes.
I think so. For m is equal to 1, the probability is 0
Yes.
because maximum can't be lower than the minimum. For m is equal to 2, the probability, there's only one outcome, 2, 2, that lies in the intersection. So that's 2 by 16 or 1 by 8. For m is equal to, sorry, that's 1 by 16 because that's just 1. For m is equal to 3, it's 1 by 8. So that'll be 3, 2, and 2, 3. And the same for 4, 1 by 8.
Okay, 1 by 16. Wait a second. I think something is wrong. 1 by 16, m is equal to 2. I think so, something is wrong. M is equal to 2, which means, okay, there'll be only one outcome. So that is 1 by 16, which is intersection 1 by 16 divided by 5 by 16. Okay, we'll do it. One, what are you asking, Preshit? Answer probability. Okay, let's do, and then I also have to solve it actually. So as you told that for the case m is equal to 1, m is equal to 1, what is the A intersection B? Can someone tell me? Like max of xy is equal to m, and min should be, we can't have min is equal to 2, so that is why it's 0 basically. No intersection is there, so 0 here. You are absolutely correct in this case. For m is equal to 2 basically. Let's try to understand that. Max xy is equal to 2 basically, and we can get the min case. Wait a second. I have an urgent call. 1 minute only. Sorry for the interruption. There was a emergent urgent call. Okay, let's proceed. M is equal to 2. So M is equal to 2. What are your views about M is equal to 2? What is A intersection B here? You write you forgot to divide all of them by P of B. Yes, you are correct. So what is A intersection B here? 1 by 16. How it is 1 by 16? Can someone tell me? What is the outcome? 2, 2. Max of 2, 2 is 2 only. And if I'll take min of 2, 2, that is also 2 only. If I'll take something else, then I can't get the same number. M is equal to 3. Can I say 2, 3 or 3, 2? Max is 3 in both the cases and min is 2 in both the cases. So 1 minute. 1 by 16 divided by P of B. P intersection B is here. I also forgot. P of B. What is P of B? Min of xy. That is what is min of B. Let us write. In which cases basically minimum is xy is equal to 2 basically. 2, 2, 2, 3, 2, 4, 3, 2, and 4, 2. These are the cases from how many? That is 5 by 16. 1, 2, 3, 4, 5. Total is 16 here. So 5 by 16. And this is 1 by 16 over 5 by 16. So basically 1 by 5. How 1 by 4? I meant M is equal to 2. M is equal, I meant for M is equal to 2 is equal to 1 by 16. Yes, I got that thing. Okay. Anyone is having doubt? What I am doing is nothing. Yes.
Sorry, those are earlier comments. There's a lag between my internet and where you're going. Please ignore them.
Okay, it's totally fine. So what we are doing is we are saying that max of xy is equal to m and min of xy is equal to 2. So 2, 2, basically, I can say that then only I'll get this. This is the only term in which I'll get this intersection. If max of xy is equal to m and min of xy is equal to 2, this is the only term. So that is 1 by total 16. And if I say that what is A intersection B over probability of B, what is the probability of B? As we saw that the samples are 5 out of 16, that is 1 by 5. Now coming to M is equal to 3. M is equal to 3. We saw that, okay, maximum can be M is equal to M, basically 3. M is equal to 3, 2, 3 in the case and 3, 2. And minimum also is basically 2. That is the two cases in this, in which the intersection will be there. So I can write here as 2 by 16 by 5 by 16. That is 2 by 5 itself. Now coming to M is equal to 4. Now M is equal to 4. Yes, can someone tell me about M is equal to 4? Yes, come on. What is A intersection B? Same as for 3, yes. What are the samples basically? Can I say 2, 4, 4, 2? And again, it is like 2 by 5 only we'll get. So these were M is equal to 1, 2, and 3, and 4. Is it clear? What about others? Any doubts? Should we proceed? Yes, clear. Okay, let's go to the next question now. a conservative design team, call it C, and suppose innovative design team, we have two design teams, call it N, are asked to separately design a product. From past experience, they're calculating the probability of team C is successful that is 2 by 3. Okay, okay. I thought you have asked for m is equal to 1. That's why I added. Okay. Now you got it, na? So probability
Yes,
of, okay. Probability of n is 1 by 2 of being successful, which means probability of innovative design team being successful is 1 by 2. And probability that at least one team will be successful is 3 by 4. What is the probability? Okay, one more thing. So let us assume that exactly one successful design is produced, which means one is successful only. From next time, I'm thinking I'll write this question prior only so that it shouldn't waste the time in the class. So what is the probability that it was designed by team N? Yes. Try to solve it.
ma'am, what's PN here?
Yes. What is?
Ma'am, what's PN here? Ma'am, is it 1 by 2?
Pn is 1 by 2 probability of n, which is probability of innovative team being successful. Probability of C, basically the conservative design team successful, that is 2 by 3. Probability of innovative team being successful is 1 by 2. 9/21, no. See where you have done some mistake. I'll wait for 2 more minutes, then we'll start. So, any one of you have attended yesterday's class, Fridays? Yesterday also the tutorial is there, no? Like, or you are attending one of them, like.
Yes, ma'am. Both lectures are being done.
Okay, okay. What are they teaching? Like, they are also, like, he's also having the problems, or like.
Only the problems, which helps in solving the next assignment related
Okay.
problems.
Okay, 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 okay. Okay, let's start. So where you guys have reached? Okay, let's start anyway. Try helping me while solving so that you can also involve. Okay, if I say how many outcomes are there, I can say either both can be successful. If sample space, I'll consider it, not sample space only. Also, I'll first consider either both can be successful. This is, let us take this as of okay, C, and then and conservative is successful, innovative is failure, and both fail.
Sorry to interrupt. We can apply Bayes theorem directly now, ma'am.
Yes, we can apply Bayes theorem, but here actually I haven't introduced with the Bayes theorem. So with conditional probability also we can do.
Okay, ma'am. Thank you.
Okay. So what is the probability of, I can say, SS plus SF? Can anyone tell me what I'm writing and what is the probability? What I've written? What is the probability of C being successful? It doesn't matter that basically other is getting success or other is getting failure. It's 2/3? Both the cases, it's successful, it's successful. These can only be the cases.
Yes, ma'am.
Now, what is the probability of SS plus FS? Now, innovative getting successful. What is the probability?
Ma'am, half.
Half, yes. Now I'm only concerned about innovative being successful. I don't care whether the conservative will be successful, whether it will be failure. Now, can you tell me what is the probability that at least one will be successful? That is 3/4 in terms of this. How can I write? Like I have written this. How can I write like this?
Ma'am,
P?
N union S.
N union S. Yes. What is N union S? Can I say? Yes, yes. You are correct only. So now I have the value of SS plus, oh, sorry. I have the value of SS plus SF. Okay, now what I have to first of all find? assuming that exactly one successful design is produced. If one successful design is produced, that is what we are assuming. What does it mean in terms of this? Exactly one is produced. Either it is SF or either it is FS. Am I correct? Probability of SS is equal to 0. No, I don't think so. Probability of SS is equal to 0. I'll come to that. Wait. Wait a second. I'm sorry. Here it is 3 by 4. Okay, maybe because of that. 3 by 4. Here I have written correctly only. Now, what is the question? Let us go back to the question. One of them, at least, what is the probability that it, assuming that exactly one successful design is produced? One successful design, can I say SF and FS? Either this is successful, either this is successful. And what we have to find, what is the probability that design is by N? Which means that this is successful. And we know that only one is successful. Can I say I have to find this? Any doubts on this? Now, in this question, we are not directly given with that we have to find with probability of A given B. We are given with the question, we have to think about how we'll go with this. Any questions about this? Then only I'll proceed. Come on.
Ma'am, can you please explain it again?
Okay, now what is given? Assume that exactly one successful design is produced. One successful design is produced. This is given. One successful design produced means we have either SS, which means not SS, both are not successful. One only is successful. So either this conservative is successful or this innovative is successful. So these both are only the sample space, and both are not failure. This is given to me. One is successful. This is given to me, and what I have to find is what is the probability that it was designed by team N, and it is designed by team N, which means this is successful. This team is successful. This is failure. Any doubts now?
No, ma'am.
Got it. So, okay. Now we have all these things. Can I find the probability of each of them? I have SF plus SS. That is 2 by 3. I can plug in here in this and find out probability of FS. What is it? Can you calculate and tell me? Yes, come on. I think it's 1 by 12.
Ma'am, 1 by 12.
Now we have the probability of FS. Here, can we calculate probability of SS? Okay, we don't need SS, but still let's calculate all the probabilities for these. Probability of SS. This is 1 by 12. Minus 6, that is 1 by 2. SS. Five by 12. Now what is left? Probability of SF. SS is 5 by 12. What is SF? One by 4. And all probabilities sum to 1. So I can say wait a second, I think. So I can now calculate this. Now someone can tell me the answer. What is the probability of Fs? Conditional probability will apply. Yes, any doubts?
আমার এখন শোনো না, ক্লাস হবে, ক্লাস হচ্ছে।
Okay, let's proceed. Come on, what is the answer? I'm not applying conditional. Tell me what is probability of Fs given both are. Let us take as homework problem only. I'll ask from you only. Nothing is this. Take the screenshot of this or take the photo of this question. I've almost solved it. Can I say the probability of Fs given SF and Fs is, what is it? 1 by 12? Okay, solve this question. Next time we'll discuss. Should we proceed now? Nothing is there, only calculating the values who are left here. Should we proceed? Am I audible? First place? Sure. Okay, the next question. Anyone wants to give the answer still? Can someone tell me how I have written this? Yes. I'm not getting any reply. Okay, remind me in the next class. Come on, let's try at least.
Ma'am, the intersection of Fs and the other set which contains SF and Fs is Fs only. That's why we take probability of Fs in numerator, and in denominator we take set of SF and Fs together.
Absolutely correct. That is what nothing it is there. That is why I was expecting the answer from you guys. Now let's proceed. Let us try to solve some, okay, I'll give you the question and then suppose If an aircraft is present in some area, radar detects it and generates alarm. With probability 0.99. If aircraft is not present, radar gives I'll say generate alarm with probability 0.1. We assume that aircraft is present with probability 0.05. Now, what is probability of no aircraft present and false alarm? This was the false alarm only. What is probability of aircraft present and no detection? I'll first solve this question and give you a related question as a homework. Okay. If an aircraft is present in a certain area, they are saying that radar detected with the probability this much. If the aircraft is not present, then also sometimes a radar detected with the false probability, like false alarm is there, that is 0.1. And we are assuming radar is present with probability 0.05. Let us take the cases as A. First of all, what we have to find, what is the probability that no aircraft is present and false alarm. So let us take that A is an event where an aircraft is present and B is the event. We can say what are the other event? I can say radar generates alarm. So we have to find no aircraft is present and still radar is generating an alarm. So in these kind of problem, when there is a big, let us try to make a tree-like structure. Like I can say that aircraft is present 0.05. Can I say, what is this? Can someone tell me what I have written here? Yes, come on.
Probability that aircraft is not present.
Yes, absolutely correct. Probability that aircraft is absent or probability that aircraft is not present. What is the probability? 0.95. Correct. Now what we are saying, if aircraft is present, then what is the probability that radar will generate an alarm? Can I write like this? If aircraft is present, radar will generate an alarm. What is the probability of that? It's given in the question itself. 0.99. If an aircraft is present in the certain area, radar detected and generate an alarm. That is what I'm saying. If aircraft is present, radar detect and generate the alarm. That is 0.99. Now similarly, what is this?
0.01.
What like can you tell me in English like what does it mean? What does it mean that probability B complement given A? What is it?
Radar
By
does not generate alarm when the aircraft is present.
when aircraft is present, then alarm is not generated. Similarly, now I can write like aircraft is not present and still alarm is generated, which is called as false alarm, which is if aircraft is not present and radar generates alarm, that is 0.1. And similarly, if aircraft is not present and alarm is also not generated, I can write it as 0.9. So for ease of like the problem, we can like make it like this. Now, what is the question? What is the probability of no aircraft present and false alarm? Which means no aircraft present and alarm is generated. Can I write like this? Can someone tell me? What is this? How I have written?
Cross multiplication in the formula. Conditional formula.
It's same conditional only, we say. So I have that A complement, that is 0.95. I have this 0.1 as well. Now the next. Now I think so you will solve it. What is the probability of aircraft present and no detection? Both the things are visible, the table, like the tree structure also, and that question also, the second question. Aircraft is present and no detection. I think we are going on conditional probability itself. We have to move forward, partitioning and everything. Okay. Come on. Now one part is already solved. Okay, so radar does, okay. Come on. What is the probability of aircraft present and no detection? Aircraft present means A and no detection means? No detection means B complement. A intersection B complement. Come on. Is there any confusion or you haven't understood? Okay, let's go. Probability. Now, what is the probability of aircraft present and no detection? Which means the alarm is what we can write. Yes, someone can help me. If I write the conditional, I write like this. This is what just I'm multiplying by this and getting this. Now, if I'll write this 1 by 5, you have written, okay, let's see. Probability of A intersection B, that is probability of A can I write like this? Because if I'll write probability of B complement given A, what it will be? Probability of A intersection B complement over probability of A. That is what we have written here. So I can write like this as well. So what is the probability of A? 0.0005. Yes, you are correct, Roshan. Probability of A is 0.0. Probability of B complement intersection.
Yes,
That is, I can say.
0.01.
Is it fine?
Yes.
I was having some other questions as well, but I think, okay, I'll give you afterwards because we don't have that much of time as well. So we have to proceed forward. If we'll have the time at the end, then we'll discuss more problems. So now, can I say the conditional probability you have understood? Like if it's not like given also probability of A given B, you can do this, or like tree structure like this, you can, if there is a huge question, you can make it like this, a table, like tree structure like, or you can solve it without it is given like it is, you have to find A given B. I'll still give you some more problems as a homework so that can be easy for you. And now I was going to solve that problem. Then I suddenly thought that it will be, I'll switch to the problem which is discussed in the class. I think I have written here. I'll write it again, it's fine. So normal coin can give us head and tail, whereas biased coin, suppose it is both head and head. I'm randomly picking up the coin and I toss it and get it hit. So what is the probability that I pick biased coin? Can someone tell me? First of all, can someone give me intuitive understanding? Like if I say that the probability is 1 by 2, is it correct, or why it is not correct? Can someone tell me about that as well? Come on. No, because one coin is biased. Yes, absolutely correct. So getting H, obviously it is more probable that more probable that biased coin is chosen because it is having more heads than the normal coin. So intuitively we can say that the biased, it will have more probability than half, but how much more? Let us try to understand. Probability that biased coin is picked and given that H appears. It was a simple question. It is solved in class as well. So B is picked and H appear. I'm just solving it so that we can get the intuitive understanding of the partitions. Probability of H appear. Applying the conditional probability here. Now, how can I write this H up here? We have written earlier as well. Like, how can I write this H? H is appearing. Come on. You can unmute your mic and tell me. You're right. The probability of, I can write it as how, like, your answer is right, but what is the understanding behind it? That is where we'll come to like partition formula. We are breaking the denominators. What do you think? These sets are disjoint by definition. Yes, these sets are disjoint by definition. And what we are saying that head can appear if basically B is picked up and if basically B is not picked up. And can I say that they both together constitute together they B and B complement together, they are sample space basically. If a biased coin is picked, what is the what we are saying is either the biased coin will pick and together cover all possible scenarios. That is what I was trying to explain. Yes, you are absolutely correct that they are together, they are disjoint, they are not having any intersection between them. Either the biased coin will be picked, either the normal coin will be picked. This means a normal coin will be picked. And these are only two cases. I can pick a normal coin or a biased coin. There is no other coin that I can pick. Then what is the probability of head? What I can say, if a biased coin is picked, then what is the intersection with the biased coin with the head, or the intersection with the normal coin? That is the only two cases in which I can get the head. And they are disjoint as well. So that is why we can write it as like this. And this is how we come up with the partition formula. Like we are decomposing our denominator, or we are trying to decompose our problem like this. That is why we come up with the partition formula, so that we can make our problem easier as well by decomposing into two parts or many other parts, where the union of them is the sample space and they are mutually disjoint. So now what is the probability of B intersection H? One. What about others? What is the probability that biased, can I say that biased coin picking up is, how 1/2 biased coin, there are two coins, I can pick one of them is biased. That is 1/2 probability, either the normal coin will be picked, either the biased coin will be picked, and probability of getting head. If I say that that basically head can be appeared, like both of the case, like if I'm picking up the biased coin, I'll obviously get the head. There is no other chance than that. So that is why that is 1. Similarly, I can write it like this. This is the same. Now, what is the probability that a normal coin is picked? 1/2. And now, what is the probability that head will appear? Can someone tell me? 1/2. Yes, yes. So I got here 1/2. 1/2 plus 1/4. 3/4. That is basically 2/3. So we understood by this example what is basically the partitioning. Now coming to partitioning definition, I think so now you have understood that basically as we are taking, they should be, BI should be mutually disjoint and should cover all the sample space as we have discussed here as well. Can I write like this? Same thing I'm writing, just mutually disjoint they are. Can someone tell me what I have written? I'll write and then I want you to explain. Yes, can someone explain me this lemma? Come on.
We're just using the formula that we had for conditional probability and dividing, cross multiplying to get the intersection, and then substituting back.
Yes, yes, yes. How we have written this term? Yes, can you tell me how we have written this term?
Well, we knew the partition covered the entire set, so the union of all the disjoint partitions have to cover the entire set A.
Yes, absolutely correct. Basically, union of all this BIs are considered covering all this sample space. Basically, this is universal only, and A intersection universal is A itself. That is how we came up with this, and that is why we have written here rather than A intersection B, I have written here A itself. So this is the like conditional probability formula itself. Just because this is the partition formula, that is why it is substituted with the probability of A here. Now there were two ways of partitioning taught in the class. I didn't bought some other example for the partitioning as well. Like I should have bought. Okay, I'll give next time the assignment maybe so that you can practice also for the partitioning. Do you want me to solve the same example, or we should proceed with the base theorem and everything? Yes. Can someone write, or I think we can proceed? Okay. So there were two ways of partitioning. I'll just give you an overview. There were two ways of partitioning. Like there was an example. Maybe next time I'll make an assignment problem so that some partitioning problems should also be there. I forgot to add. So basically, what they are trying to say is that partitioning should be done very carefully. It can result into a very complex problem as well, and it can result into a very, as we have seen that how we are arranging the sticks. Basically, the question was, what is the probability that stick is in the kth hole and it is visible from the left? So the first time what they have tried to do is they have tried to arrange in increasing order and they have considered all the permutations there. So, and the second time they are only considering that kth position is tallest at all. What we want, that kth position should be tallest at all. Like I want to see that kth stick only. Like in the kth hole only, that stick should be visible to me. At the kth position, that stick should be visible to me. That is how the second partitioning technique is done, and it is how easier than the first one. That is only told in that example. Now coming to, if you want, again go through the example. If you want, the next class I'll do, or now also I can do that. Independent events. We discussed the example before also, like if I toss the head and I toss it again, the head, then my second event is not dependent on the first. I'm tossing the coin twice. Now suppose I like my second time when I'm tossing, it doesn't depend about like what was the first outcome. This is basically the independent event. Am I right?
Yes, ma'am.
Now, okay. Now there was also given, suppose events A and B are independent. What I have written, can someone tell me? It is not
There is no
dependent.
effect of
Continue.
there is no effect of B
Yes, and B is not
in
having
happening of A.
yes. One is not dependent on other. Yes. I can directly write probability of A into probability of B in this case. Now one more lemma was given, that if A intersection B is equal to phi, then, and they are not empty sets also, A and B, then A and B are dependent always. They are not, they can never be independent. How? If my probabilities of intersection is 0, which means that I know that independent events probability of A into probability of B, and I know that if I'm saying that they are happening with any chance, the probability is happening with any chance, and they are not 0, which means or both of them are not 0, which means that the multiplication will not be 0, and which means that they are dependent and they can never be independent. And the converse is not true, basically. The other example was taken, suppose I have a red ball, I have a blue ball. Suppose I have one bucket, two baskets, I have two blue balls, two red balls. Now, what is the probability? Now, suppose okay, there is a question. Theoretically, if both are mutually exclusive, one happens, then other doesn't happen, then there is a constraint for one event from other one. I didn't get your question. Please, can you unmute and explain so that we all can discuss? One happens, then other doesn't happen. Okay. Then there is a constraint for, okay. You are talking about this only. Then both are dependent. Yes. Okay. Now coming to back to this. If we say that, suppose I picked up the red ball, first event is that I picked up the red ball, then what is the chance that I'll pick up the B ball? Obviously, that is dependent on that whether which ball I have picked first. I can say they are dependent events. But if I'm doing the replacement, can you tell me what is replacement? It will be occurring so much in the probability that you shouldn't confuse with this term replacement. You should know. In this context, what is the replacement here?
Then sample space remains the same.
Yes. Yes. We are. Can I say I'm keeping up the sample space remain the same, or I am keeping back the ball? In that case, if I'm keeping the ball back, which means that is independent event. I'm first picking up the red ball, then keeping it back. Then I'm picking up. What is the probability of picking up the blue ball again? It is independent of the first event. If there is a replacement, we are seeing that these are independent events. But if there is no replacement, I can say that they are not independent in this case. Okay. Now coming to Bayes' theorem. Can I write like this? This is basically the Bayes' theorem here. Maybe next class we'll go through the proof and all, how we get this. Or I can write like, now can someone tell me what I'm doing in the denominator again? Yes.
I'm using the partition formula.
Yes. So we are simply using the partition formula. Yes, you are right. Applying partitional formula. We are here writing it. So, like in the last class itself, we have discussed an assignment problem of Monty Hall fallacy. Here, like there at that time, we were trying to understand the intuition behind it. Now, basically, let us try to solve it through the Bayes theorem. So basically, we like last class we discussed that there are 3 closed doors, and right like this only 3 doors are there. Monty is basically whole handling the show, and in behind the one there is a car, and behind 2 doors there are goat here. Behind one door there is a car, and behind 2 doors there is a goat. And you are asked to pick a door, and you don't have to open it. After you pick the door, suppose you pick the door 1. After you pick the door, basically host Monty opens the goat door. Now, what is the probability? Like second door, Monty has opened. Now, what is the probability that, or like what is it like? Should you switch the door, like you selected the door 1, and now should you switch the door 2, 3, or you should remain on your path, like okay, door 2 is goat now, I got to know, but still I shouldn't switch from 1 to 2. That is what let us try to understand. We tried to understand through the intuition based last class, but let us try to understand through Bayes' theorem. Now, door 1, suppose we are picking. Door 2, Monty, in which goat is there. And door 3, and what is the probability of door 1? I can say that is 1/3. Now, what about the events? The car is behind any of the door, I can say. And Monty has opened the door 2, basically. This is 1/3. Can you tell me what is this? Can you tell me what I have written here?
Monty choose gate 2 given that I choose the gate 2.
So how it 1 by 2?
Because there are only 2 other options when I choose the first gate.
So if I choose the door 1, only 2 options are left, door 2 or door 3. So the probability is basically 1 by 2 of choosing them, I can say. Now what I have to find is that whether I'm choosing door 1, is it correct or not? I should basically change my choice. So probability that I am selecting door 1 and Monty has chosen door 2, that is given to me. I can now write it as conditional probability. I know M2 if D1 is given to me. What is the probability D1 is there? We saw that any gate choosing is 1 by 3. Okay, that is fine for us. What is the probability that if door 1 is chosen by us and Monty picks up the door 2, that is 1 by 2. But we don't know the probability of M2. So here again the partitioning thing. This you have understood the denominator. Same by partitioning because we don't know about M2. Now, what is the probability that this is the same as the numerator itself? What is this? Can someone tell me? Zero. Why it is zero? He can't open a door we have already opened. No, we haven't opened door 2. We have opened
he chooses from the remaining doors. Ma'am, he chooses from the remaining doors.
No, what is the question is, what is the probability of D2 of and given what is the probability of M2 given D2? What is D2? First of all, 1 by 3. Now what is this? It is 0. But how?
Because Monty can't choose the door in which he has the prize hidden. So
Yes.
one of the 2 can be chosen only.
Yes, yes. You are also right. And in the chat also someone has written, yes, he can't choose the door in which the car is there. So that is why it's 0 basically. So what is the probability then again this, and what is the probability of choosing M2 given D3?
1.
How 1?
Because he can't choose both 2, so it will be only one door left to choose. So out of that.
Yes. So basically he can't choose the door 1 is chosen by us and he can't choose that. So only one door is basically left. So that is why he's forced to open the M2. And now coming to here, it is basically 1 by 6. 1 by 2, that is 1 by 3, which is less than 50%, and which means that he should basically switch the door. Any doubts? Any doubts? Okay. So next class, or I should give an assignment problem. I always think though, I'll bring the assignment PDF or I'll okay, share the link of the drive in the chat itself. so that you can solve the questions and we can discuss, or you can send it to me. Okay, and one more thing. This is my mail ID if you have any doubts regarding any question. And suppose you are solving the assignment. I can't actually solve the assignment until it's submitted. So if you are solving the assignment, if you have any doubt, I can do one thing. I can solve the related question related to that and discuss in the class itself. And something is urgent, and if assignment is the next day, then I can help you in solving the related question, not the actual question there. And if you have any doubt in any topic, you can tell me prior only so that we can discuss in the class. And as I told you that the videos, like today or tomorrow, I'll upload this video also. So this is the YouTube channel in which you'll find the probability last lecture. And last time I have taught RL, you can find those videos also if you are interested. Basically the probability videos you'll find in this. Now coming to random variable. I think assignment 1 is left, okay. Or the next time we'll solve the assignment 1 and assignment 2 on in the starting itself. Is it fine? Because I have also not seen that. So yes, okay, random variable. Can someone tell me what is random variable and now why we come up with this random variables? If we are saying that sigma algebra and everything, why we are coming with the random variable concept? I'll just introduce it and in the next lecture we'll go in detail. Yes, come on. We map an event to a variable of a function, yes. Can I say many times we need numerical values? We can't what is in sigma algebra? We are working on the subsets in the sets. Basically we are not working on the numerical values. But if I say how many number of heads are required, can I say that numerical values are needed there? We can't work with the subsets there. That is why we come up with the numerical value. And as you said, we map on the subset of that event, like it is defined as that event to a variable of the function. We map that event. That is what is the random value here, random variable basically. So in the next class, we'll go in detail about the random variables. Any doubts? And I'll try to give some problem also to get that quantitative idea. Yes, you are correct. So basically, how many times that event has occurred? Any doubts? How was the session? Any feedback? Anything which you want that the class should be like this, like some more intuitive understanding, more problems, so that we can achieve.
Sorry.
Yes.
Do you mind writing your email in the chat? All right. Is that IIT?
IIT basically.
Okay. So that's a double T there, right?
Yeah.
Thank you so much.
Okay. Any other doubts? Okay, thank you, class. Let's meet in the next session. And if you have any doubt or you want that something should be discussed in the next class, like give me, write a mail. Can't we focus on more problems? Yes, sure. Like today also you saw that I tried focusing. I was going through the conditional probability. So much time was taken that Bayes theorem and everything, partition, everything is left. So I just rushed up. Session was good today. Thank you so much. Okay. Session was great. Thank you. Thank you so much, class. Let's meet in the next session.